Good morning, everyone. Today, my team will be presenting the real-time and social trend correlation for PR management. This is our topic, and it's covered by myself, Zhang Chao, Sid, and Zoe. Today, we're going to investigate how social media and news volume trends can be mapped onto each other to identify or help manage media proliferation of news. Moving forward, in today's world, where new age media and publication is very limited in control, news are no longer limited by geographic restrictions, and people can be affected by news from a different country. For example, the Jesuit Charlie movement is a very good example on how a particular controversial piece of news can affect a different region. Proliferation of social media also do not help, and the stakeholders that we are interested in are people who has a reputation to manage, people who are doing the security business, as well as risk and crisis managing as well. Information is a very important tool. And we are getting it from Meltwater. I'm working on Meltwater, which we are able to supply real news and social media data, which possible analysis such as top application, where we can use the data to plot influencer network and to do risk assessment and global trends, policy making, and even crisis response. In our case studies, we like to focus on terror attacks, and the stakeholders' pain is that information nowadays are being disseminated randomly, and it's very hard to manage as people might give fake information and causes panic. So the solution will be to use volume as a proxy to map the data together to identify who is the first to the world sources and to be able to mitigate those false sources from passing on. One of the tools that we're using is sentiment analysis via text analysis. We're using the hit sentence as well as the headline via NLP technology to understand what people's sentiment are about when they are talking about news. This will help us identify upcoming crisis areas so that we can assess assets to the area, and as well as to mitigate false statements or false news from spreading from the area.
Based on what Angela mentioned just now, we are still at the first stage of the big vision. Here are 3 problems we are going to cover in the project. As a whole, what are publications and social media talking about the terror attacks since the Paris attack? And are there any differences among different countries when talking about the terror attack? To solve 3 problems, we have 2 datasets from Meltwater, news dataset and social dataset. Our analysis was based on the post content in the social dataset and the hit sentence on the news dataset. The analysis procedure consists of 4 steps: upload data to cloud, import data to Jupyter, text preprocessing, and visualization. Natural Language Toolkit (NLTK) is a platform for building Python programs to work with human language data. It provides easy-to-use interfaces. We use it for text preprocessing. Our datasets are located on cloud. We first upload data to Amazon S3 and then import the data to Jupyter launched on EC2. This is the code snippet we use to import the data. Text preprocessing is to represent a piece of text as a sequence of words. It contains 3 major steps: tokenization, stop word removal, and stemming. Tokenization is to identify individual words. Stop word removal is to remove unimportant words, and stemming is to represent words with their stems. In the project, we use 2 visualization techniques to better present the results: word cloud and bar chart. A word cloud is a graphical representation of word frequency, and it shows the keywords that are mostly talked about. Bar chart is used to show the polarity distribution. Later, my teammate Sid will talk about the main findings of our project.
Moving on, visualizations here actually talk about the terrorist attack and the result from the publications. So the word cloud here actually talks about the terror and the attack. These are the words that have been talked about. The sentiment here is majorly negative, but it has a highly neutral content to it. Moving on, taking the visualization of social media into account, Here, as we can see, the religion Muslim and the terror attacks being related to the Muslim religion, Islam as such, as we talked about on the social media. The bar chart here actually describes how negative the feeling is. Comparing both the charts, our visualization actually suggests the following patterns. While the publications associate the attacks with terrorists and terrorist organizations, social media as such associates it with religion in general. Sentiment in publications was overall negative, but there was a high neutral element to the sentiment as well in the publications, whereas social media was highly negative with very low neutral element to it. Moving on to the challenges that we faced, there were multiple sources of data in multiple formats. The data that was collected was multilingual, hence it required translation and cleaning. There was no specific standard or format in social media data. Sentiment analysis, as such, is a highly contentious domain of NLP. Getting accurate sentiment was a very big challenge for us.
The first was the challenges of analysis. The source of data is massive. Data was searched and aggregated by keyword. Thus, it came from many major sites without credit. So some mistakes and rumors are unavoidable. And why we choose Cloud, Jupyter, and Spark? First, there is no need to download and upload data files. Incredible time could be saved here. Second, cloud processing is completely real-time, which keeps data fresh enough. Third, hardware restriction is avoided. If processing by Excel, utilization of IM is limited. With most of the cloud applications features random devices, increase coding, data mining, plus supporting and manage broadening functions. Spark is quite new in big data family that is fast, widely accessible, easy to use, and perfectly integrated with main data programming languages such as Python, Scala, and Java. It's also usable in Jupyter, and that is why we choose them. To move forward, we need more speed and input. For example, if there is a platform for other journalists to share their real-time news, it would be a wonderful source for our data file performance. The reliability of use must be considered. Besides, this integration could speed up the procedure to update flashes for people. The last step is to build a usable interface for all the users to aggregate and dive data for analysis. And the huge real-time data could be helpful when doing some sentiment analysis and understanding people's attitude towards some very events. All in all, this platform aims to be practical in helping its stakeholders gain a fast access to new things and make proper responses. Thank you.